Welcome, Algebra 3. We're in Lesson 62. We're going to talk about abstract coefficients in this part of the lesson. We have a two-parter, so not super long, but you know how we've always used the coefficients to help us when we have a system of equations, so we know how to combine via substitution or elimination. Like for instance, in this set of, this system of equations, in order to get this y term, since it's already opposite of one another, to match so we can cancel it, we divided the top by 2 and we multiplied the bottom by 2. So that gave us the opposite terms so that we could cancel and solve for x. And then we found that x is 49 over 9. We can do the same thing when we don't know what the coefficient is. We can find that abstract coefficient term that will give us the ability to eliminate. So let's try out a practice problem. So here is our system of equations, and you see we have a variable stand-in for the coefficient, and we need to solve for y. So the first thing that we need to do is we are going to multiply by the opposite coefficient, and one of them is going to be a negative. So for the first one, let's multiply this by d. So then if this is multiplied by d, then actually I'm just going to use a little dot to multiply by d, then this is going to become dAx plus dBy is equal to dC. And if we multiply this by negative a, then we get a negative dAx plus, or I should say minus, minus AEY is equal to a negative AF. So this gives us a value, though, that we can then eliminate. So we have that taken away from us. And then what we end up with is dBy minus AEY is equal to dC minus AF. So now that we have that going on, we can factor out the y just like we normally would. So y is equal to dB minus AE equal to dC minus AF. And then we just divide by this factor, and y is going to be equal to, and I'm just going to put these in alphabetical order for the sake of just our conventions that we usually use, which is probably the way I would put it in Jupyter. So this would be BD, because that's alphabetical order, minus AE. And that would be how you would solve for y in a given situation like this. We just use the letter that is the variable for the coefficient and multiply by the opposite, just like we did when we had a value for that coefficient. We're just making it match. One of them's positive, one of them's negative, but we make it match so that we can cancel that out, which allows us to then get a y term that we can use. All right, that is the first problem. Let's do another problem like this just so we can kind of practice it a little bit more. So here we have a system of equations where we have the same variable, but they have a subscript which changes them. So be very, very careful when you're dealing with subscripted variables. That can make it really tricky, and you could get them confused. So for this one, let's get rid of the y term because we're solving for x, right? That's what we need to do. So we are going to multiply this one times b squared, or b sub 2, and I'm going to multiply this one times a negative b sub 1, and this is going to give me let's see, a sub 1 b squared x plus b sub 1 b sub 2 y equal to b sub 2 c. This one then becomes a sub 2, or a negative a sub 2 b sub 1 x plus, or I'm sorry, that would be minus b sub 1 b sub 2 y equal to negative b sub 1 c sub 2. And I'm sorry, this was c sub 1 up here. So that allows for this one to cancel this one because these are identical. So those go away. Then that gives me a sub 1 b sub 1. I'm sorry, I'm getting those confused already. So you see how difficult this can be. A sub 1 b sub 2 x minus a sub 2 b sub 1 x is equal to b sub 2 c sub 1 minus b sub 1 c sub 2. Now we want to solve for x. So we have the x's on the same side, so we just factor out the x, just like we did before. So we have a sub 1 b sub 2 minus a sub 2 b sub 1 equal to this, as it remains the same. And then we just divide everything by the second factor here in parentheses. So x is equal to b sub 2 c sub 1 minus b sub 1 c sub 2 divided by a sub 1 b sub 2 minus a sub 2 b sub 1. And that would be your answer, because it's already in alphabetical order. It's just, you've got to pay attention to each little individual coefficient. You're no longer actually multiplying times coefficients and getting a value. You're just combining variables until you get, you're mixing and matching. It's like a memory game almost. You multiply and put things together until you get the opposite of the other. But it's the same principle that we used when we have a coefficient. If you think about it, it's also going back to Algebra 2, where we'd be given these complex problems and told to solve for a specific variable. It's the same type of principle in that way. So it's something you've done before, just maybe not with this application. So that's all I have for 62A. Do the practice problems that go along with this part of the lesson, and then watch the video for 62B. We're talking about linear variation.